today we're looking at AC and DC. So far, when we have considered circuits, we have considered coulombs moving from the positive side of our cell round the circuit to the negative side of our cell. A bit like this. That is called direct current, where the charges, our coulombs, only flow in one direction. Now AC stands for alternating current. Alternating because it changes. And by changes, we mean it changes direction. So now our coulombs don't just travel from positive to negative, but they constantly change direction, like this. I'm a bit dizzy now. In the UK, the AC supply is 50 Hertz, which basically means that my coulombs change direction and back again 50 times per second. So like this. Obviously, I can't show that very accurately. Anyway, the frequency of my mains AC supply is 50 Hertz and it is held at a voltage of 230 volts. DC current is the kind of current that you get from cells or batteries, and AC current is the current that you get from mains. So what does AC and DC look like on an oscilloscope? This graph here shows DC current. You can see that my line is all above the x-axis of my graph. That tells me that this current is flowing in one direction. And this graph here shows AC current. You can see that my graph goes between above the x-axis and below the x-axis. When we were talking about the frequency of my current, and we decided that in the UK, the frequency of the main supply is 50 Hertz. That means that a coulomb goes towards the positive side, turns round, goes towards the negative side, and then turns back towards the positive side 50 times every second. So what about this graph here? This graph is still a wave, but it does not cross the x-axis. So whilst the size of the current changes, it gets larger and then smaller and then larger and then smaller, the direction of the current doesn't change. Remember, the direction is to do with whether the line is above or below the x-axis. You'll see more of these graphs when you look at generators. Okay, to understand the next part, you need a basic understanding of waves, including frequency and time period. If you're unsure about those, check out the waves videos first. So we have an AC wave on an oscilloscope. Each Y division is set to 2 volts and each X division is set to 20 milliseconds. That is giving my graph its scale. Each division on the Y-axis being worth 2 volts means that my y-axis goes up in 2s, and each division on my x-axis being worth 20 milliseconds means my x-axis goes up in 20 milliseconds. So what is the peak voltage of this wave? Well, the peak, which is here, is 2 squares above my x-axis, and since each square is worth 2 volts, that is 4 volts. And what about the frequency? First, let's find the time period of my wave. This is one complete wave here, and there are a total of 8 squares across my x-axis. Remember, each square was worth 20 milliseconds, so if one whole wave is 8 of them, then one whole wave takes 160 milliseconds. To convert into seconds, that is 0.16 seconds. Now I can find my frequency by using the formula that we looked at in waves. Frequency is 1 divided by time period. 1 divided by 0.16 is 6.25 Hertz. Hope you found that helpful. Please do download the notes. Thanks for watching.